Okay, upwards and onwards to section 2.3 and the product rule. Now you might think that given two functions or two polynomials would be a better way to see it, like these. That all you would have to do is take the derivative of this one, which is 6x, and the derivative of this one, which is 3x squared, and multiply them to come up with the derivative of 18x to the cube. That is not correct. That will not give you the derivative. So for product rules, unlike when you add them, which is the sum rule, when they're added, you can do individual derivatives and add them together. Product rule has discovered, and you can see proof in your book, that to come up with the correct derivative of this formula, you have to take this function, just as is, and multiply it by the derivative of this second one, d over dx, so the derivative of that one. And then you have to add it, the product rule, to the derivative of the first one, so d over dx, times the second function. Okay, and so this we just leave as is. What's the derivative of this one? I just did it above before. It's 3x squared. So I replace this whole thing with 3x squared. I found the derivative of it. And then what's the derivative of this one? I found it before. It's 6x. So I replace this whole thing with 6x times this function. Now, sometimes your teacher will want you to simplify this. He'll want you to expand it through and come up with an overly simplified equation. However, this currently is indeed the formula for the derivative of this function right there. And if you have an x value, let's say 2, you can simply plug the 2 in everywhere you see x and then solve it instead of simplifying the equation. All depends on how complex this equation is. Essentially, you have a derivative formula which will give you all the answers you need. So for instance, if I took x is equal to 2 here, 2 squared is 4 times 3 is 12. I get 12 minus 1 in this bracket. What's 12 minus 1? 11. Times 2 squared is 4 times 3 times 12. 11 times 12. It's clear that that's 121. Then I have a big old plus here. And then when I put 2 in here, what's 6 times 2? It's 12 times, when I put 2 in here, I get 8 plus 8, which is 16. And 16 times 12 is the same as 16 times 10 plus 16 times 2. So I get 192. When I add 121 to 192, I get 392, 402, and then I got to add 11. 413, I believe. So essentially 8 off that. Yeah, 113. If I take 8 off this, I have 113. If I add 8 onto that, I get 200. And you can see that it is, oh, there we go, caught a mistake. 313, my bad. And how did I do that? Well, because I knew I needed to borrow 8 to make this nice and even. So I'm going to borrow 8 from this 121 and add it to there to make it 200. And when I borrow 8 from this 121, I'm left with 113. What's 113 plus 200? A lot easier to see that it's 313. So that's some math tricks. So 313, I have now the slope of the tangent when x is 2 for this function. Notice I did not have to simplify it, but there will be cases when your teacher wants you to simplify it. Let's move on. So the book will summarize in an incredibly awkward way, the second one anyway, the product rule. It's important you keep master notes somewhere, and there's the product rule. It essentially says that when your function is the product of two polynomials, to find the derivative, you must take the derivative of the first function and multiply it by the actual second function. Then you must add that to the actual first function times the derivative of the second function. Sounds complicated, especially when written this way, which just says find the derivative of u multiplied by the function v, add it to the function u that's multiplied by the derivative of v. It's a lot easier when you're actually using numbers. Let's say you got this, and we've got this. And obviously I could just solve this one a little bit easier than, I could expand it quite easily. But instead, I know from the function rule that I must find the function of this and multiply it, or the derivative of the first one, and multiply it by the actual function of the second one. And then I must take the actual function of this and multiply it by the derivative of that. Okay, and I can just make it my life easier and put derivative here and derivative here, just to remember. So what's the derivative of this? 6x. That one's easy. So now I have 6x times this entire thing here. I can simplify it or not. Now I must do the derivative of this one. What's the derivative of this one? It's 8x plus 6. So right there, because it's two terms, I should probably still keep it in brackets. And so you can see that expanding this and expanding that and adding together is a pain. But right now, I have a derivative equation that I could use. Now obviously if there's similarities between the two, you might be able to factor stuff out, make it simplified. And there will be cases where your teacher asks you to simplify it. But ultimately, remembering that this is the product rule will help you. It says that take the derivative of the first polynomial multiplied times the actual polynomial. Take this first polynomial and multiply it by the derivative of the second one. Product rule. Get it out of your book. Then they go on and say, okay, they give you a couple good examples, and they also show you proof of how they came up with the product rule. The proof is a little bit complicated, especially here where they add and subtract this polynomial out of nowhere, but it's valid. Then they give you some examples, and then they ask you some complicated questions like, okay, they're asking you to find for -1. So you would take this polynomial and multiply it by the derivative of that. Then you would add the derivative of this polynomial times that. And they walk you through it. And notice here, they don't simplify it. They get up with a long equation for the derivative, and then they just plug in their value, because they know expanding and simplifying this would be just as long as expanding the first polynomial in the first case and just using the sum rule. Now, here's an interesting case. They say, what about when you have 3 polynomials multiplying each other, not 2? What happens if you have this? And I'm going to jump right to the conclusion as well, so that you can either just jump to the conclusion or you can follow me along and skip whatever you want. So they found out that when you're finding the derivative of this function and it's 3 polynomials times each other, what you do is you take the derivative of the first one and multiply it by the other 2 functions in their exact format. Then you add, you keep that function, you multiply it by the derivative of the second one, and you multiply it by the actual function of the third. And then you add, the first function stays the same, the second function stays the same, and you take the derivative of the third function. And they did that, and the proof is quite clear in the book, and it's much clearer if you look at the book. They did that, please, there we go, by grouping these functions and treating them like one function. So the product rule, so that I would just take this function and multiply it by this function, so by the derivative of that function. And then I would add, and I would just take this function and multiply it by the derivative of this thing. But here's the trick. To find the derivative of this one, we must apply the product rule within there. Okay? So the product rule says that I must now instead take this h of x, and it's going to be added, open a big bracket, the function here times the derivative of the second function. I'm just doing the product rule again, plus the function of the first function, f prime of x, get rid of this crap so it's less confusing, times the second function. So you can see I've taken the derivative of this one, multiplied it by the actual function, and I've added the derivative of f of x times g of x. And then when I distribute this through here, and here's where you're going to see it more, I get h of x times this first one and h of x times this second one. Something happened with my, oh yeah, okay. h of x times the first one, and h of x times the second one. So now I can get rid of this. And remember that this is going to be added. And we can see how they came up with it now. There's the derivative of h. There's the derivative of g. There's the derivative of f. And they're multiplying just the other functions when they do it, and they're all being added together. And that's how they came up with the proof. So you can see that you can do it with as many functions as being multiplied as possible. You just keep grouping them and applying the product function, but there's going to be simpler ways down the road. Then they're going to teach you something they call the power of a function rule for positive integers. That's too much of a mouthful. You're going to discover it's very similar to something called a chain rule. Okay? So when you have a function, and this is a lot easier if you just learn, sometimes the book makes life very confusing. But if you look at something, let's just take a simple one. Let's take 3x squared plus 4x. And if that's to the cubed, this is actually called the chain rule. So you can sort of ignore that because later on we're going to learn the chain rule. The chain rule says that, and I'm just going to skip to the end. How do I find if this is f of x, how do I find the derivative of that? The chain rule says I take the power, put it in front. Okay. Take the power, put it in front. So might as well get my proper symbols in here. And I'm going to multiply it times the function. There we go, time the function. And I'm going to lower the power by 1. So it's very much like the power rule, except I'm also going to multiply this whole thing by the derivative of the content of the bracket. Well, what's the derivative of this? That's 0. The derivative of this is just 6x. That's right there. So I can just get rid of that, replace it with 6x. So we discover that the derivative of f of x is actually the power rule first, so 3 times the function, now squared, times the derivative of what's inside the brackets, times 6x. And they got this way, they figured this out by using the same thing we did with the product rule. So what is this thing cubed? It's simply itself, times itself, times itself. And they discovered from the last one that you take the derivative of this, and you add it to the derivative of the second one, and you add it to, this is just the product rule over again, the derivative of the third one. So get rid of this derivative. The derivative of the third one. Well, what do you see here? Well, I see this times itself. That's the same thing as this squared. What do you see here and here? Well, I see those brackets times itself. That's the same as that squared. And by the way, this is derivative symbol, so I should actually just put a dx here so you know what I'm doing it. And what do I see here times itself? I again see the same bracket times itself, which is the same as this one here. So bring it down. God damn. There we go. And so I see the square of this times the derivative, the square of this times the square of this times the derivative, the square of this times the derivative of the content. So I essentially see 3x squared plus 4 to the power of 2 times the derivative of the content. So you can see that that's how they derived it. There's the power rule, and there's, you got to do the derivative of the content. You got to multiply by the derivative of content. And we got that from the product rule, the extension of the product rule. And you discover a lot of these rules are extensions of what we learned last. So then they want you to learn that. They want you to practice a bit. Then they give you a summary here. And then they want you to practice using it. Okay. I don't want to spend too much time on that because your teacher should be teaching you how. And it's much faster to learn by example. here we go. Well, I could just find the expansion, and I know for a fact that if I just expand it, I just get that minus 4x, and then I can just use the independent power rules that I learned before. I know it's going to come out as 2x minus 4. But let's use the product rule. The product rule, because obviously they're starting you off simple, right? Product rule says I'm going to find this function and multiply it by the derivative. I'm just going to mark that with that. And I'm going to add it to this function multiplied by the derivative of this. And I'm just going to put a dx over it. Okay? Well, what's the derivative of x minus 4? It's simply 1. And what's 1 times x? It's simply x. And what's the derivative of x here? Well, it's simply 1. So clearly they've given you a simple one. Why did it go wrong? 2x minus 4. Oh, there we go. So then I'm left with x plus x minus 4, which is 2x minus 4, which is the same as the expanded version. You say, well, expanded was a lot easier. And yeah, if you encounter something like this, expanding it is a lot easier. That's what we've been doing. But obviously, when you get to something like that, it gets tougher and tougher. And believe me, it's going to get tougher and tougher. But they just want you to practice the power rule. Sorry, it's called the product rule. I keep saying the power rule. The product rule. Okay, so the product rule says I'm going to take this, and I'm going to multiply times the derivative of that, and I'm going to add it. I'm just going to put a dx over it. I'm going to add it to this function times the derivative of this function, dx. Now, if you want, you're allowed to take all your products here and just assign them. Say h of x is equal to f of x times g of x. And you're allowed on the right to say, well, my f of x is equal to x squared. And my f prime of x, therefore, is equal to 2x. And my g of x is equal to 2x minus 1. And therefore, my g prime of x is equal to 2. And then you can just write down, instead of doing what I'm doing here, the product rule, which says f of x times g prime of x plus g of x times f prime of x. And you can simply replace wherever I see f of x, I'm going to replace it with x squared. And wherever I see g prime of x, I'm going to replace it with the 2 that I found. And then wherever I see g of x, I'm going to replace it with this that I wrote down. And wherever I see f prime of x, I'm going to replace it with that. And I can see that it's quite easy to do it in these steps. Or I can do it the way I did it over here. Either way that works for you, you do it the way that works best for you. As long as you follow the rules of math, it will work. So what's the derivative of this one? It's simply 2. And try to remember that it's going to be, I accidentally erased that, it's going to be times x squared, which is that one. And what's this one? That's okay. What's the derivative of that? 2x. So this is 2x. Now you can expand it, but right now, you indeed have a derivative formula for h of x. So if you have values of x, you can plug it in and just solve it. But right here they say simplify your answers. So they just want you to get used to it. Personally, I think simplifying is a waste. Before I can add it, I have to expand this. So I get 4x squared minus 2x. So that replaces that. And when I add my like terms, I get 6x squared minus 2x. And if you wanted to be really anal, you could then take 2x out of both of those, and you're left with 3x minus 2. But I don't see, minus 1. But I don't see the point in doing that step. This is actually the simplified version. This, we're starting to factor again. So that's as simple as it gets. I don't see the point of doing it this way if you're just trying to come up with a number. But if your teacher wants to see that you understand the process, then yeah, you should you should do it the long way. Okay, so let's try it the way I just mentioned. I'm going to assign a value, a function, instead. To each of these, I'm going to call this one f of x, and this one I'm going to call g of x. And on the right, I'm going to say g of x is equal to this function. F of x is equal to this function. And then I'm going to say f prime and g prime, and I'm going to solve it. So what's the derivative of that? It's 2. What's the derivative of that? It's 3. And then I'm just going to write down the product rule, which says f of x times the derivative of g of x plus g of x times the derivative of f of x. And then I'm just going to take my lovely things up here, and wherever I see that it fits properly, that's what I'm going to do. A little bit easier, actually. Depends what you're used to. Just don't have things left over. Then I'm going to expand this, and I get 6x plus 4 plus the expansion of this, 6x minus 21. So I can see that my like terms are the numbers and the 6x, so I get 12x minus, what's 4 minus 21? Minus 17. That's the simplified derivative of this thing. And when it's simplified, it's quite clear that, yeah, it's easy to see. I can just plug in my x once and do the calculations. But if you're rushed for time, right here at this stage, plus that, you have a perfectly useful derivative formula where you can plug in x's, solve the bracket, multiply by 2, plug in x's, solve the bracket, multiply by 3, and then add them. Nothing wrong with this derivative formula. But if your teacher's after simplify, that's what he's going to do. Okay, I'm going to continue on, and I'm going to do these. And it's probably the last one that's more important. So, and I might have to stop early because it's dinner. I got to do dinner soon. All right, put them in brackets. It's a lot easier. This is the same as that. And so now I'm going to just assign them f of x and g of x. And I'm going to say f of x is equal to x minus 3. And that f prime of x is equal to 1. That's the derivative of that. And I'm going to say g of x is equal to x plus 3. And the derivative of g of x is 1. So you can see the derivatives are quite simple. So I almost don't have to write this down, but it's going to be the product rule. And I wish I just kept a copy of the product rule, plus. And because the f of x and the g of x are just 1s, I can pretty much just get rid of them. And I'm going to be left with this, plus this. Only because the derivative's worth nothing. Well, what's x plus x? 2x. What's minus 3 plus 3? 0. So that's it. That's the derivative of that function. Now you could have expanded this function easily and gotten x squared minus 6x. It looks like I actually made a mistake here. Plus, yeah, no, I didn't make a mistake. So when I add the 2, I get 2x. X squared, oh yeah, because it's plus minus, there is no middle term, sorry. And then minus 9. It's a difference of 2 squares. So it's quite clear to see that the derivative of that is just 2x. And actually, so in that case, you know, it's much easier to expand. Oh, I did something wrong, didn't I? I forgot about the minus 1. Okay, sorry. Let's go back. So, f of x is easy enough. F of x is equal to x minus 3. F prime of x is easy enough. It's just 1. Here's the tricky part. The derivative of this one is the chain rule. So it's minus 1 x plus 3 to the negative 2 times the derivative of the content, which is just 1. So that's g of x might be this over here, but the derivative is much more complicated. By the way, this is the same as 1 over x plus 3 when the whole thing down here is squared. That's what the minus 2 means. It just means send it down there. Okay, so this is g of x, and this is g of x up there. So the chain rule says that we're going to take f of x, and we're going to multiply it by the derivative. And then, okay, and then I'm going to add it to the derivative of f of x, which is just 1, times the original function. So really, I'm just going to add it to the original function. Oh, but don't forget that the original function is to the negative 1, so it's the same as 1 over this. Easy to forget, isn't it? Now it's clear to me that, and I've got to now replace the f of x. It's clear to me that expanding this could be a pain in the butt. Right? And expanding it might be useful when especially since I have a perfectly useful derivative function right now. This is a derivative equation right there. I can just plug values of x in and solve instead of like finding the common denominator. But since the question wants you to simplify, notice how many mistakes I made because I forgot it was f of 1. Since it wants you to, I just want to look at these so they don't ding again. There we go. The only way you can add this is if you make this denominator the same as that, which means I have to multiply this right side by itself, top and bottom. So it becomes that. And it becomes squared at the bottom. Now I can add them. Let's distribute this first, though. So I get minus x plus 3, and I can add plus x plus 3, all of it divided by the common denominator. Boom, like that. So what's minus x plus 3? And it's 0, so I get 6 over x plus 3 squared. This is the simplified formula of the derivative. Notice how many mistakes I made. Okay. There's no trick to this one. It's the same rule. Find the derivative of this one, derivative of that one, and then it's f of x times the derivative of the second one, plus the function of the second one times the derivative of the first one. This derivative is 35x to the 6. And this is 0, so nothing. And the derivative of this one is 2x minus 2. So there's the derivatives, and there's the functions. And just plug them in. Same thing with this one. And I'll put the derivatives up above. 2t minus 2t. Oh, minus 4t. That's the derivative of this. That's the derivative of that. Put it in the product equation. And this one I did. Woo! Complicated. Use the product rule and the power function rule to find the, oh man. So these are really just headache ones because of this time it takes. So I don't know if I'm going to do them all. But the rule says, the product rule says I have to find the, so just assign them. We're going to call this f of x. We're going to call this a g of x. So g of x is equal to this. And g prime of x is equal to 1. So g prime of x isn't a big deal. But f of x is this. And the derivative of it needs the chain rule. And then you have to multiply it by the derivative of what's inside. What's the derivative of what's inside? Times 5. What's 5 times 3? 15. So you can just simplify it a little bit here. 15. And this here is the derivative of f of x. Not too bad. Okay, then you just follow the product rule. It's going to be f of x times the derivative of g of x. Well, good news is the derivative of g of x is just 1, so it's just going to be f of x. Let me just put that there. Plus g of x, which is this, times the derivative that we found over here. Not too bad. I'm just going to put the 15 in front of the whole thing, just to make my life easier. It's not too bad. You can see expanding this is a pain. And that's why they say do not simplify. So now you can see that if I have a value of x, I can just plug it in and solve it. And thank you, do not simplify. All you have to do is find out this that are over here, plug it into the product rule. Now, and the chain rule. So, it looks like they're the same over and over again. This one's probably the only complicated one. So just make one of them f of x to make your life easier, and one of them g of x. And on the right, you would write f of x is equal to this function, and then you figure out the f prime of x. The f prime of x uses the chain rule, and says we're going to be 4 times the content to the power of 3. I'll just steal a 3 up here. Don't forget your brackets, though, because it can really screw you. Oh, come on. There we go. And what's the derivative times the derivative of the content? 2x. So we can just simplify that a bit and call it, call it 8x up front. So that's the derivative right there. Then you can assign g of x here. That's g of x. And the derivative is going to be the chain rule to the power of 2 times the derivative inside. The derivative of the whole thing inside is just 2. It's 2 times 3, 6. So right there, I have the derivative of g of x. Now, I can just write f of x times the derivative of g of x plus g of x times the derivative of f. And wherever I see it, I can just replace it and get full marks. Get rid of any of my mess. Plus g of x times the derivative of f of x, which I found right there. Boom. And I can even, just to simplify, put my 8x up front as a multiplier. Don't forget your powers. And I can put my 6 up front of this as a multiplier. Which means if I have a value for x, let's say 2, I get 4 minus 9, 4 minus 9, minus 5, minus 5 to the power of 4, 25, 125, 625. 625 times 6. Then I got to multiply it. Did I say 2? Or did I say 5? I said 2. So I got 4 minus 3, 3 squared, 9. So I got 6 times 625 times 9. Break out your calculator. And then I add it to, what's 8 times 2? 16 times 4 minus 1, 3. 3 to the cube times 27. 2 squared minus 9 minus 5 to the 3 times minus 125. So you can see that this whole thing's going to become minus. You multiply all these numbers. You multiply all these numbers, and then instead of adding, because of this minus 125, you subtract this number from that number. But all they want is the formula, because then it's a workable derivative formula that you can use. The other ones follow the same rules. So I can try the last two, I think, maybe. When is it not appropriate? Oh, geez. When your parents tell you not to use it. When is it not appropriate? Give an example. Square root function. That still works, though. It's going to be to the half. When you have an absolute value. When you have probably a product within a product within a product. or a function within a function within a function like this. 3 times 4x plus 9x squared plus 3x plus 2. I don't know, probably like that, something like that. I don't know, ask your teacher. Let this be that, express f of x in terms of b f x, okay. So the product rule, why? Why? It's just the product rule. Don't get that one. Just restating it with different things. Determine the value of this once they give you a 2. So they probably want you to, well, you don't have to simplify it if they just want the answer. Let me do one of these. Maybe the first and the last one before I take a break. Okay? And I'll continue in a bit. This one's just lengthy. Torturous. It's why people give up math. But they have to drill it into you. Okay. Product rule. Let's ignore for x is equal to 2 for now. Let's call this f of x. And let's figure out its derivative. It's 7. So I'm just going to put an f above it. Let's call this g of x. And let's figure out its derivative. It's 1. So that's nice. So the derivative over here is nice. So the answer to this will just be the function f of x times the derivative 1, which is just the same thing, plus the function g of x times the derivative of f of x. If I expand it, I get 2 plus 7x plus 7x minus 3. So I get 14x minus 1. And then when I plug in 2 here, I get 28 minus 1. 27 is the slope of the tangent for this function when x is 2. It's the same thing we were doing before. But let's see if I could have gotten 27 if I plug in 2 way back here before I simplify. So 2 times 7 is 14 plus 2, 16. And 2 here minus 1 times the 7 becomes minus 7. So I get 16 minus 7, and I get 9, a totally different answer. So let's try that again. Oh, you know why? That's 21. Right here, I did this wrong. Beautiful. Good thing I checked. So the expansion here is not 14x minus 1. The expansion is 7x minus 21. So it's 14x minus 19. So for x is 2, I get 28 minus 19, which is 9. There we go. So the original one actually didn't produce me as many problems. So 2 in here, when I calculated, also produced me 9. Both of these are technically derivative formulas. One is just simplified. I personally don't see the point in simplifying unless your teacher asks you. These are the same. It's the same. This, you're going to have to use the chain rule for, no, that's just the power rule for this one, and the chain rule to find the derivative of that one, but it's still the same. This, you just use the chain rule twice. So if I'm going to do anything, it's going to be the first one. Now notice they give you 3 here, so that's tricky. If you want to get around that, you can just expand it once, and then you're going to only have 2 functions. But the rule for that is this function times the derivative of that function, this function times the derivative of that function, and this function times the derivative of that function. But so let's do the middle one. The middle one. So let your f of x be the first one. Let your g of x be the second one. And to find the, so this is f, I'm just going to call it f instead of f of x and g. To find the derivative of that, I have to use the chain rule. So it's 5 times that to the 4 times the derivative inside, which is 2. So now the 2 can go times the 5, and I get 10 in front. So that is f prime right there. The chain rule for this one says 4 goes in front times that, which now becomes the power of 3, times the derivative of the inside of the brackets. What's the derivative of this thing? 3. What's 3 times 4? 12. So I can just rewrite this up front as 12. And that is the derivative of g. Now I just use my product rule, which says f of x times the derivative of g plus g of x times the derivative of f. And I just replace them each time. There's my f of x times my g prime of x, don't forget the 12, plus my g of x times my derivative, which I kind of, oh no, I solved it already, of this. Now it looks confusing, especially with all my leftover markings. And I'll just get rid of everything. No, 12 is there. Yeah, and I can now just put the 12 up front. And I can put my 10 up front. Put these closer together. But they're going to give us a value of 1. And notice they're going to give us softball ones here. Minus 1. So you plug in minus 1 there. You get minus 2 plus 1. So that's minus 1 to the power of 5 simply becomes minus 1. Minus 1 here becomes minus 3. Plus 2 becomes minus 1. To the power of 3 becomes minus 1. Now remember, they're multiplying here. Minus 1 times minus 1 times 12 is plus 12. So that's plus 12. Then over here I've got to add. Minus 1 here is minus 3, plus 2 is minus 1. Minus 1 to the power of 4 becomes positive 1 times 10 is positive 10. So I've got positive 10 times. Minus 1 is minus 2 plus 1. Minus 1 to the power of 4 is plus 1. So 10 times 1 times 1, 10. So I get 12 plus 10, 22. So the answer is, because this is now a derivative for my function, a workable derivative, 22 when x is the slope of the tangent when x is minus 1 for that equation. And I use chain rule, product rule to do it. I'm going to stop and continue later. Might have to break this into part 3 because they take so long.